else would be worth in 2020? We multiplied 320,000 twice because that was the ratio that we had been using. We estimated 2005 that would be worth 240,000. We picked because it was halfway between. Then we used this formula, initial value, constant rate, decades, cents, right? So this is how many times we're going to actually do the exponential application to it. And then we went and checked our work for this, and we were a little bit off, right? For the 2005 value, we went up 4.5 years. There's no rhyme or reason to why that's so far off. Remember, the whole real estate thing was a prediction anyway. And now we're on number 15. Is everybody with me? Does everybody have this kind of, you have it fresh in your mind now from a few days ago? It's been a little bit. Exponential growth. Penny activity. Who can remind me what the penny activity was? What was it? Avery? Yeah, you're going to want that over $1,000 a day. Right? Okay. So we have number 15. Recall from page 3 that in order for a function to be exponential, the values a and b have the following restrictions. A can't be 0, b has to be greater than 0, and b can't be 1. Explain why each restriction is necessary in order to produce an exponential function. Okay, are you having trouble finding yours, Logan?
I don't know, mine just like fell apart like at the beginning. I tried to put it back together and I don't.
That's okay. Let me get you another paper, and then you can just, I'm sure you're all caught up to here. Right. You're welcome. Okay. So A can't be 0. Why? What would happen if A was 0? I'm sorry? Yeah, your answer would be 0, right? Because anything times 0 is 0. So that'd be bad. Answer would be 0. That's not showing any kind of growth. Why can't B be lower than 0? Think about, we're talking about, remember, B was the initial value, or the constant factor, your ratio. If your ratio is less than 1, are you really changing anything? Nope. So B has to be greater than 0. Or else nothing changes, right? If you don't have a ratio of something, and your factor of something, then you're not growing. So there would be no exponential change. I forgot to put or 1, 0 or 1. Greater than 0, not 1. Nothing is changing. Right? You have to be multiplying by 2, 3, 4, something. You have to have growth for something there. How are we doing? Crystal clear? Sure, Mrs. Marsh. Okay. An exponential function that models growth can also be written using this form, where r is the growth rate. In this case, since the value of the house doubles every decade, the growth rate would be 1. 100% of the value of the house is added. And b would be 1 plus 1, or 2, which is the constant ratio. Clear? Yeah? This is a little muddy. We're going to write the word muddy here. We're going to apply it, and it's going to make sense. Seriously, write the word muddy. Do it, MJ. But we are going to use this actual situation. It's just going to be a lot easier than what these words say. So go ahead and turn to page 5. Put little numbers here. Page 5. Can I have someone please read to me about radon? If you have a basement, you'll kind of know about this. Addison?
Radon, a naturally occurring radioactive gas, was identified as a health hazard in some homes in the mid-1980s. How do you say it?
Radon.
Since radon is colorless and odorless, it is important to be aware of the concentration of the gas. Radon has a half-life of approximately 4 days. The half-life is the amount of time in which a radioactive element decays to half of its original quantity. Tony's grandparents' house was discovered to have a radon concentration of 400.
Don't worry about that. Yep.
Renier chemist isolated and eliminated the source of the gas. She then wanted to know the quantity of radon in the house in the days following so that she could determine when the house would be safe.
Okay, so how many of you have a basement? I guarantee your basement has some sort of device that's measuring radon at all times. Did you guys know that? Did you know that, Addie? Like, you should definitely have something in your basement measuring that, right? It has something to do with, like, being underground. If things aren't properly ventilated, right, it can cause some problems. I know for a fact when I was growing up in the 1980s and we had a basement, we did not have one of those things measuring it. It wasn't even a concern. Odorless, gas, colorless. Nobody knew it was a thing until it became a thing. So ask your parents about it. Ask them what your radon level can be. I'm curious. Can at least one of you ask your parents tonight? What?
I actually might because I live in it.
There you go. You're going to want to know, Avery. That's going to be a very important thing to you. Okay. So let's answer these questions. What is the amount of radon in the house 4 days after the source was eliminated? Okay, so the half-life is 4 days. So that means every 4 days, it's going to be half of what it was before. So after 4 days, how much radon is in there? 200. PCI/L. Explain your reasoning. Well, every 4 days, it decreases by 1/2. How do we know that? They told us, right? They told us the half-life was 4 days. Compute the difference in the amount of radon from day 0 to day 4. So on day 0, it was 400. On day 4, it was 200. So what's the difference?
200.
Yeah. You guys were looking at me like, is it really that easy? Yep. What's the ratio? It has a half-life. 1 to 2. Remember with the previous example, the home values were increasing, so we had a whole number ratio. The radon value is decreasing, so we have a fraction. Yeah. Let's go ahead and complete this table on the next page. So this isn't 1 day, this is 1 half-life, right? So how many days was that? 4. The concentration was 200. Difference is 200. Ratio 1 to 2. Sorry, you guys can't see that. There you go. So what's my next row going to look like? 8. 100. 100. 1 to 2. The next one's going to be 12, and this is going to be 50. 50, 1 to 2. The nice thing about exponential growth and decay is it's a pattern, right? What is the pattern? What's the pattern between these and between these? Grace?
The difference is always the concentration.
Yeah. Always cut in half. Right? Yes. The constant ratio was the same, right? The concentration ratio. Okay, so something you guys that a lot of students have trouble with, and I'm going to just, don't put this on your paper. I'm just going to use a little sticky note here. Okay. Let's pretend we have something that starts out with, let's just say 300 of something. We'll say 300 liters. I don't know of what. And the half-life is 5 days. So on day 0, I would have, what is that? We'll just say amount. 300. This time, my day is going to be 5. What's this number going to be? 150. And then on day 10, I would be at 75. So sometimes people get really caught up in the half part and it being an equal number for the days, like an even number. Don't get caught up in that. Like whatever the half-life is, it's going to be those increments. It doesn't have to be even increments like 2, 4, 6, 8, or 4, 8, 12, or what have you. That's just something I've noticed in the past that algebra students get caught up on. They want these to be even numbers, and 5 is not an even number, right? So don't let that get in your way. You'll know it when you see it. We'll be doing lots of these practices. Okay, let's go ahead and graph this. This is fun. So we can do single increments here. And then it looks like we're going up by 40s. So my x and y values are the half-life and the concentration. This 4, 8, 12 situation has nothing to do with my x and y values for my ordered pairs. Okay, so this is my x and this is my y for my ordered pairs. If you want to keep going, 4 would be 25, 5 would be 12.5, and so on. Great.
Wouldn't day 2 be 100 instead of 120?
Sure would. Thank you. Okay, so here's where people have, like a lot of people struggle, and I don't want you to freak out, Avery. But will there ever be no radon?
No.
There's going to be some. but there are acceptable levels, which will not hurt you, right? So if I keep going in half and half and half, am I ever going to go below the x-axis?
Yeah.
No, I'm not subtracting anything. I'm just cutting it in half. I'm going to have super, super, super tiny values, but they're still going to be positive. I'm never going to go below the x-axis because I'm not subtracting anything. I'm just keep continuously making it smaller and smaller, right? Okay, turn the page. Okay, Renee needs to know the concentration of radon in the house after 20 days. How many radon half-lives are in 20 days? 5. Predict the concentration after 20 days. All right, we'll finish after lunch.